On June 24th, 2026, the European Space Agency released a single photograph containing 60 million individually visible stars, built from 26 hours of raw observation time, spread across 9 overlapping telescope pointings, and stitched into a 6 gigapixel mosaic that is, right now, the largest high-resolution visible light image of the center of our own galaxy ever produced by human instruments. That is not a simulation. That is not an artist's impression. That is a real, physical, light-gathered photograph of the middle of the Milky Way, and it was taken by a spacecraft called Euclid, a telescope most people have never heard of, quietly orbiting 1 million miles from Earth, doing something that sounds almost boring on paper and is, in reality, one of the strangest scientific missions ever attempted. Euclid was not built to take pretty pictures. Euclid was built to hunt for something that has no color, no light, no surface, and no agreed-upon explanation. It was built to hunt for the two things that make up 95% of everything that exists, and that we still cannot directly see, touch, or fully understand. Dark matter, dark energy. And, in trying to find them, Euclid keeps stumbling into images that are somehow more unsettling than anything a special effects studio could invent, because every single one of them is real. Let's start with what Euclid actually is, because the mission itself is stranger than most people realize. It launched on July 1st, 2023, from Cape Canaveral, riding a SpaceX Falcon 9 rocket out toward a gravitationally stable point in space called the second Lagrange point, the same neighborhood where the James Webb Space Telescope sits, about 1 million miles from Earth on the side, facing away from the Sun. From there, Euclid began a 6-year survey with one central goal: to map more than a third of the entire sky, cataloging the shapes, positions, and light from an estimated 1.5 billion galaxies, reaching back across 10 billion years of cosmic history. Think about the scale of that for a second. 10 billion years. The universe itself is roughly 13.8 billion years old, so Euclid is essentially trying to photograph the universe's entire adult life, watching how galaxies clustered, stretched, warped, and moved as the cosmos expanded around them. The reason scientists care so much about this isn't really the galaxies themselves. It's what the galaxies reveal about the invisible scaffolding holding them in place, and the invisible force pushing everything apart faster and faster with each passing year. That scaffolding is dark matter. That pushing force is dark energy, and together they make up the vast majority of the universe, while the stars, planets, dust, and everything we can actually see and touch make up less than 5%. We are, in the most literal sense, blind to almost everything that exists. So how do you photograph something invisible? You don't, not directly. Instead, you look for its fingerprints, and that brings us back to that 60 million star image released in June of 2026. This picture was taken in March of 2025, but ESA held onto the data, processed it, cleaned it, and released it more than a year later as part of what they called Euclid's Quick Data Release 2, timed to mark 3 years since the telescope's launch. The image shows the crowded, glowing core of the Milky Way, an area astronomers call the galactic bulge, a dense bubble of billions of stars sitting at the very center of our home galaxy. French astronomer Jean-Charles Coyandre, who works directly on the Euclid mission, described this moment simply, saying the team decided to point Euclid at the brightest part of the sky, and that it worked, in his words, superbly. What makes the image valuable isn't just the star count, staggering as it is, it's the resolution. In a region this crowded, with stars packed so tightly together that older telescopes could only see a blurred wash of light, Euclid can pick out individual stars, one by one, across an area of sky roughly 22 times the size of the full moon. Inside that image, scientists spotted something they were not specifically looking for: a strange feature in a cluster called NGC 6397, one of the closest globular clusters to Earth, where researchers noticed a gap in the population of faint, cool red dwarf stars that had never been documented before, a subtle break in the pattern of stellar brightness that hints at something in the physics of how these ancient stars evolved that we do not yet fully understand. That's the pattern with Euclid. It goes looking for one thing and finds something else entirely, something nobody predicted, hiding in the data the whole time. Inside that same mosaic sits a smaller glowing red structure that researchers have labeled G00, 583-00, 870, an emission nebula located about 26,000 light-years from Earth, deep in the direction of the galactic bulge. It's a cloud of gas, lit up and energized by young, hot stars nearby, and it stands out in the image, like a wound of fire against the golden haze of ancient stars surrounding it. The overall color of the region comes from the sheer number of old, cool stars packed into the bulge, giving the whole area a warm, yellowish glow, occasionally cut through with streaks of pink and purple where gas and dust catch the light differently. Scientific American described the center of the Milky Way in this image as looking almost like it's on fire, lit with pink, purple, and gold. That description isn't an exaggeration for effect. If you pull up the actual image, that's exactly what it looks like. A furnace at the heart of our own galaxy, sitting there this entire time, 26,000 light years away, and we are only now seeing it in this kind of detail. But there's a deeper purpose behind this image beyond simply being beautiful or eerie. This region of the sky is exactly where NASA's upcoming Roman Space Telescope will later search for hidden planets, using a technique called microlensing, where the gravity of a foreground star briefly bends and brightens the light of a background star as it passes in front of it, revealing the presence of planets too small and too dim to ever be seen directly. In order for that technique to work, you need to be able to tell individual stars apart in an incredibly crowded field, and that is precisely what Euclid's image now allows scientists to do. In other words, this single 6 gigapixel photograph isn't just a record of what exists. It's a map for a future hunt, a hunt for worlds we cannot yet see, hidden in a region so dense with starlight it used to look like nothing more than a glowing smear. Now here's where things shift from awe-inspiring to genuinely unsettling. Because while the Milky Way image shows us something beautiful hiding in plain sight, Euclid's very first major discovery, made almost by accident, revealed something that sounds like it belongs in a piece of cosmic horror fiction. It happened in September of 2023, only weeks after launch, during a phase when the spacecraft's instruments were still being calibrated and focused. The images coming back to Earth at that point were deliberately blurry, not yet meant for scientific use, just test data to confirm the hardware was working. An archive scientist named Bruno Altieri was reviewing this raw, out-of-focus data when he noticed something strange in one of the images. The faint, ghostly outline of a ring of light wrapped around the center of a nearby well-known galaxy called NGC 6505, sitting about 590 million light-years from Earth. He flagged it. The team looked closer, and once Euclid's instruments were fully calibrated, they confirmed it. This was an Einstein ring, a rare and specific kind of optical illusion predicted by Albert Einstein back in 1915, caused when the gravity of a massive foreground object is so strong that it physically bends the path of light traveling from a galaxy far behind it, wrapping that distant light around itself into a nearly perfect circle. Let that sink in for a moment. Gravity is bending light, not blocking it, not reflecting it. Bending it the way a lens bends light passing through glass, except in this case the lens is an entire galaxy. And the thing doing most of the bending isn't even the visible mass of that galaxy. It's the dark matter surrounding it, the invisible material we cannot see directly, but whose gravitational pull is strong enough to warp the fabric of space itself and drag the image of a galaxy 4.42 billion light-years away into a glowing halo around a much closer one. Professor Thomas Collett from the University of Portsmouth, who worked on modeling this ring, pointed out something particularly haunting about the discovery. NGC 6505, the galaxy at the center of the ring, was first observed and catalogued by astronomers back in the 1880s. For over a century, people looked at this galaxy through telescope after telescope, and not one of them saw the ring. It was there the entire time, hiding in plain sight, wrapped around a galaxy humans had already been studying for more than 100 years, and it took Euclid's resolving power to finally reveal it. That's the part that should genuinely unsettle you. It's not that something new appeared in the universe, it's that something had been there all along, invisible, not because it was far away or faint, but because our tools simply weren't sharp enough to see the shape it was hiding in. And the ring itself is only the beginning of the story, because once scientists had a confirmed Einstein ring to study, they realized they could use it to do something remarkable, weigh the invisible. By carefully modeling exactly how the light from the background galaxy was bent and distorted as it passed through the gravitational field of NGC 6505, researchers were able to calculate how much dark matter must be present and how it must be distributed inside a galaxy sitting nearly 600 million light-years away, without ever directly detecting a single particle of it. Connor O'Riordan, one of the scientists on the project, said Euclid is going to revolutionize the field with a volume of data on gravitational lensing that has simply never existed before. And that phrase, dark matter substructures, deserves a second look because it implies something specific and deeply strange. Dark matter isn't spread out evenly like a fog. According to these models, it clumps. It has structure. It has denser regions and thinner regions, invisible architecture built from a substance we cannot see, layered throughout galaxies like scaffolding inside a building whose walls have been stripped away, leaving only the skeleton visible through its effect on the light passing near it. This single Einstein ring is far from the only one Euclid is expected to find. Scientists estimate that as the mission continues its survey, cataloging more than a third of the sky, it will ultimately identify around 100,000 strong gravitational lenses, a staggering increase from the fewer than 1,000 that had been cataloged by all previous telescopes combined across the entire history of astronomy. before Euclid even launched. 100,000 rings, arcs, and distorted halos of bent light, each one marking a spot in the sky where an invisible mass is strong enough to warp the path of photons that have already been traveling for billions of years. And this isn't a distant future promise, it's already happening. In April of 2026, ESA launched something called Space Warps, a citizen science project hosted on the Zooniverse platform, inviting ordinary people, not professional astronomers, to comb through never-before-seen Euclid images and help identify these rare gravitational lenses by eye. The reasoning behind this is almost unsettling in itself. There is now so much raw imagery flooding in from the single telescope that professional scientists cannot keep up with reviewing it all manually. They need the public's help just to look at everything Euclid has already captured. Somewhere in that backlog of unreviewed images, there could be dozens, maybe hundreds of distorted rings of light representing concentrations of invisible matter that no human being has laid eyes on yet. Which brings us to what might be the most genuinely disturbing discovery to come out of Euclid's early data so far, something scientists are now calling, quite literally, a million solar mass enigma. Using gravitational lensing data, an international team of astronomers identified something in the distant universe that has never been seen, never emitted a single photon of light that we've detected, and yet has a measurable, calculated mass of roughly 1 million times that of our Sun. They didn't find it by pointing a telescope at it and taking a picture, because there's nothing to photograph. There's no glow, no heat signature, no visible boundary. They found it purely by observing the way it warped and distorted the light of a distant background galaxy passing near it, the same fingerprint technique used to detect the Einstein ring, but scaled down to something far smaller, far darker, and far stranger. Researchers describe this object as showing traits consistent with being a tiny, extremely faint galaxy, almost entirely composed of dark matter with barely any stars at all, but its internal structure defies easy explanation. It sits there in the depths of space, a million suns worth of gravitational pull, completely invisible, detectable only by the way it bends the light of everything behind it, like a shadow with mass, a hole in the universe, shaped exactly like a small galaxy should be, except nothing inside it shines. Sit with that for a second, because this is the part that tends to actually keep people up at night once they understand it. Dark matter, by current scientific understanding, makes up over 80% of all the mass in the universe. It doesn't absorb light. It doesn't emit light. It doesn't reflect light. It interacts with the rest of the universe almost exclusively through gravity, meaning it can sit there, invisible, all around us, all around every star, every galaxy, every planet, silently shaping the structure of everything we can see while remaining permanently undetectable to our eyes and even to our most advanced cameras, unless it happens to warp the light of something behind it, just enough for us to notice the distortion. Somewhere out there, according to Euclid's own data, there could be dozens or hundreds of objects just like this million solar mass enigma, dark, structured, gravitationally massive clumps of invisible material scattered throughout the cosmos, and we would have absolutely no way of knowing they exist unless, purely by chance, a distant galaxy happens to line up directly behind one from our vantage point on Earth, bending its light just enough for a telescope like Euclid to catch the distortion. For everyone we've found this way, how many more are out there that simply haven't lined up correctly for us to notice yet? Euclid's earliest full-color images, released back in May of 2024, only reinforced how much of the universe was hiding just outside the edge of what previous telescopes could resolve. One of those first images showed the star-forming region Messier 78, roughly 1,300 light-years away in the constellation Orion, a nursery of interstellar dust and gas glowing in deep purples and oranges, where new stars are actively being born inside a swirling cloud of material. Chiandra described it poetically at the time, saying, "Bright things are trying to come out," referring to the young stars still gestating inside the thick clouds before eventually breaking free of the dust that formed them. Another of those early images captured a galaxy cluster called Abell 2390, a massive gravitational grouping of galaxies where astronomers observed faint, curved arcs of light stretched around the cluster's core. Arcs that, once again, are caused by the same gravitational lensing effect, distant background galaxies having their light bent and smeared by the sheer collective mass of the cluster in front of them, much of which is, once again, dark matter that cannot be seen directly, only inferred from its effect on everything around it. And then there are Euclid's so-called deep field images, released in March of 2025, covering patches of sky designated Deep Field North and Deep Field South, among others. These aren't images of single objects or nearby regions. These are images built by staring at what looks, to the naked eye, like nothing at all, an apparently empty patch of dark sky, and holding that stare for long enough, and with enough sensitivity, that the darkness resolves into tens of thousands of individual galaxies, each one a separate island of hundreds of billions of stars, some so far away that the light captured in these images left its source billions of years before our own sun or Earth even existed. Inside these deep fields, scientists cataloged galaxies of wildly different shapes and structures. Spirals, ellipticals, irregular smudges of light representing galaxies, still in the process of colliding and merging, captured in a single frame that maps out three-dimensional structure across billions of light years of cosmic history. This is the beginning of Euclid's real mission, the wide, deep survey work that will eventually cover more than a third of the entire sky. And every single deep field image released so far is, in a sense, only a preview, a tiny keyhole glimpse into a survey that is still, even now, only a fraction of the way complete. What all of this adds up to is something bigger and, frankly, stranger than any single image. Euclid isn't just taking impressive photographs, it's slowly assembling the most detailed three-dimensional map of the universe ever constructed, tracking not just where galaxies are, but how their light has been bent, stretched, and distorted by the invisible material surrounding them, and how the space between those galaxies has been stretching apart over billions of years due to the mysterious force scientists call dark energy. The ultimate goal is to build two separate maps from all this data. One is a gravitational lensing map, tracing the invisible clumps and structures of dark matter scattered throughout the cosmos by observing how they warp the light of everything behind them, essentially drawing an outline around something you can never see directly, using nothing but its shadow. The other is a map of something called baryon acoustic oscillations, essentially frozen ripples left over from the early universe, sound waves that propagated through the hot plasma of the newborn cosmos, and then froze in place as space expanded and cooled, leaving behind a subtle pattern in how galaxies are distributed that scientists can use to measure exactly how fast the universe has been expanding at different points in its history, and how that expansion rate is connected to dark energy. Why does any of this matter? Why should any of this feel unsettling rather than just academically interesting? Because what Euclid is really doing, image by image, is confirming just how little of reality we've actually been able to perceive up until now. For the entire history of human astronomy, from the earliest naked eye observations of the night sky to Galileo's telescope to Hubble to James Webb, we have been looking almost exclusively at the 5% of the universe that happens to emit or reflect light. Stars, planets, gas clouds, galaxies made of visible matter. And this entire time, according to the best current models in physics, the other 95% has been sitting there all around us, all around every object we've ever photographed, completely invisible, completely undetected by direct observation, silently exerting gravitational influence on everything we can see. Dark matter isn't some rare exotic substance hiding only in distant corners of the universe. According to current models, it's threaded through our own galaxy, through the neighborhood of our own solar system, potentially passing directly through the Earth, through your own body, right now, as you listen to this, completely undetectable, interacting with almost nothing except through the pull of gravity. Euclid isn't discovering that dark matter exists somewhere out there. Euclid is slowly mapping out exactly where the shadows of it are thickest, and every single Einstein ring, every gravitational arc, every distorted galaxy shape it finds is one more confirmed data point proving that this invisible scaffolding really is there, really is massive, and really has been shaping the structure of the entire universe since almost the very beginning of time. There's something almost vertigo-inducing about that idea once you actually let it sink in. We like to think of the universe as the things we can point a telescope at. Stars, planets, nebulae, galaxies glowing in the dark. But according to Euclid's entire mission, according to the very reason this telescope was built, most of the universe is not the part we can see. Most of the universe is the invisible pull holding the visible part together, an unseen hand, one that has never once directly revealed itself, that we can only detect the way you detect a person standing in a pitch-black room, not by seeing them, but by watching the way the air moves around where they must be standing. Every image Euclid sends back, from the 60 million star mosaic of our own galactic core, to the glowing red nebula hidden inside it, to the impossible ring of light wrapped around a galaxy people have been observing since the 1880s without ever noticing it was there, to a million solar mass object with no light of its own drifting somewhere in the depths of space, all of it points to the same underlying, quietly terrifying truth. We are surrounded by things we cannot see, embedded in a universe that is mostly invisible to us, and the only reason we know any of it is there at all is because every so often, by pure chance, its shadow falls across something bright enough for us to notice. Before we get to where this is all heading, it's worth understanding why scientists even started believing in something as strange as dark matter in the first place. Because it wasn't Euclid that invented this mystery. It was inherited from decades of earlier astronomers who kept running into the same impossible math. Back in the 1930s, an astronomer named Fritz Zwicky was studying a cluster of galaxies and noticed that the galaxies inside it were moving far too fast to be held together by only the visible mass he could measure. By all the normal rules of gravity, the cluster should have flown apart long ago. Something invisible had to be holding it together, contributing far more mass and far more gravitational pull than anything visible could account for. Decades later, in the 1970s, an astronomer named Vera Rubin studied the rotation of spiral galaxies and found the exact same problem on a smaller scale. Stars near the outer edges of galaxies were orbiting at speeds that should have flung them off into deep space entirely, unless there was a massive invisible halo of extra material surrounding the galaxy, providing the additional gravity needed to hold everything in its orbit. For decades, this remained a strange anomaly, something astronomers had to account for mathematically, without ever being able to directly observe it. Euclid is the first mission built from the ground up, specifically to hunt this anomaly across the entire observable universe, cataloging it not just as a strange correction factor in an equation, but as a physical, structured, mappable presence with real shape and real density, varying from galaxy to galaxy, cluster to cluster, exactly the kind of structure you'd expect from something with genuine physical form, even if that form is completely invisible to every instrument except the gravitational shadow it casts. That history matters because it means every unsettling image Euclid produces is really the final visual confirmation of a suspicion that has haunted astronomy for nearly a century. Zwicky and Rubin never got to see anything like the Einstein ring around NGC 6505. They never got to see a calculated, isolated, million solar mass dark object rendered as an actual measurable shape in a data set. They had to infer the existence of this invisible material purely from motion, from galaxies spinning too fast and clusters holding together too tightly. Euclid is now putting an actual visual signature on what used to be pure mathematics, turning decades of abstract suspicion into an actual catalog of specific locations, in the sky where this invisible material is dense enough to leave a fingerprint. Every new lens Euclid finds is, in a very real sense, a photograph of something that scientists have believed was there since before most of our own grandparents were born, but that no one had ever actually seen the shape of until now. The Milky Way image itself also didn't happen in isolation. In March of 2026, ESA highlighted a joint observation where the Hubble Space Telescope and Euclid combined their data to zoom into what astronomers nicknamed a cosmic eye, a distant gravitationally lensed galaxy whose light had been bent into a ring-like structure eerily similar in shape to a giant eye staring back across billions of light years. Pairing Hubble's extremely sharp but narrow field of view with Euclid's much wider survey capability let scientists study this object with a level of combined detail that neither telescope could achieve alone. It's a preview of the kind of collaborative work expected to define the next decade of astronomy, with Euclid providing the wide, sweeping map of where interesting objects exist across huge sections of the sky, and other telescopes like Hubble, James Webb, and eventually Roman zooming in on the most compelling anomalies Euclid flags along the way. In a strange sense, Euclid is functioning like a scout, sweeping enormous stretches of the universe looking for shapes that don't quite add up, so that more specialized instruments can be pointed at exactly the right coordinates afterward. That red dwarf brightness gap found inside NGC 6397 deserves a little more attention too, because on the surface it might sound like a minor technical footnote buried inside a much flashier headline about 60 million stars, but it's actually a genuine open question in stellar physics. Globular clusters like NGC 6397 are some of the oldest structures in our galaxy, tightly packed spheres of ancient stars that formed billions of years ago and have been slowly evolving together ever since. Red dwarfs, small, dim, incredibly long-lived stars, make up the bulk of the low-mass population inside these clusters. When scientists using Euclid's data examined the brightness distribution of these red dwarfs inside NGC 6397, they found an unexpected dip, a gap in the population where a smooth, continuous distribution should have been. Nobody currently has a fully confirmed explanation for why that gap exists. It could be connected to how these stars process and burn hydrogen at very specific stages of their evolution, or it could point to something about the cluster's formation history that we don't yet understand. Either way, it's a small, quiet reminder buried inside a much louder headline. Even our own galaxy, the one we've been living inside and studying for the entirety of human history, still has basic structural mysteries that a sharper camera can accidentally stumble into. And this is really the through line connecting everything Euclid has captured so far. From the star-forming clouds of Messier 78 to the accidental Einstein ring, to the million solar mass enigma, to the quiet gap in a cluster's stellar population. None of these were the specific headline discovery Euclid was launched to make. Euclid was built for one overwhelming patient task: to slowly, methodically survey more than a third of the sky over 6 years, building the largest three-dimensional map of galaxies ever assembled in order to measure, with unprecedented precision, exactly how dark matter and dark energy have shaped the structure and expansion of the universe across 10 billion years of cosmic time. Everything else, every ring, every enigma, every gap, every glowing nebula, is essentially bycatch. Unexpected discoveries that fell into the net while the telescope was doing its actual job. And if the mission is still producing results this strange, this early, with the vast majority of its planned survey work still ahead of it, that alone should tell you something about how much more is likely still sitting out there, unrecorded and unexamined, somewhere in the roughly two-thirds of the sky Euclid hasn't even reached yet. Euclid still has years left in its survey. It has only mapped a small fraction of the third of the sky it's ultimately supposed to cover, which means the images released so far, as strange and unsettling as some of them already are, represent only the earliest chapter of a much larger story. If a telescope less than 3 years into a 6-year mission has already stumbled onto an accidental Einstein ring that a century of prior astronomers walked past without ever seeing, already identified an invisible million solar mass object hiding in the depths of space, already needed to recruit the public just to keep up with reviewing its own backlog of unexamined images, it raises an obvious and slightly uncomfortable question. What else is sitting out there right now in data Euclid has already collected, but nobody has looked at closely enough yet to notice, waiting the exact same way that Einstein ring waited around NGC 6505 for over 100 years? Invisible, not because it was hidden, but simply because nobody had looked at it quite the right way until they finally did.